Okay, I'm back, and for this you are going to need, now ideally a tape measure would be the best thing to do, but you could do it with just a ruler if you have to. So you're going to put a candle at one end. Okay, then the magnifying glass is going to go in the middle, and then you're going to have a piece of cardboard over here somewhere. Okay, and now the let's say, for example, that your focal length of your magnifying glass just turned out to be 5 inches. That means that you're going to need to put the candle further away from the magnifying glass than 5 inches. That's very important, or else the experiment won't work. So whatever your focal length was that you have just calculated or measured outside with the sun, you're going to need to put the candle a little bit further away, or maybe double the length if you want to. It's up to you. So you can really pick any distance that you want as long as it's further than the focal length of the lens. Alright, now you're going to light the candle. The candle flame, the light from the candle flame is going to pass through the lens and then is going to appear on the piece of cardboard over here. So you got candle, lens, screen is over here. Now you're going to need to move the screen back and forth until you get a bright image of the candle flame on the screen. It's going to need to be pretty dark in order to do this. So it doesn't have to be pitch black, but it does need to be dark enough that you can see the image of that candle flame. So be careful, don't set fire to anything when you're doing this experiment. Okay, now you're going to first note, is the candle flame right side up or is it upside down? So make note of that. Okay, then you're going to measure the distance in centimeters from the candle to the magnifying glass, and then you're going to measure the distance from the magnifying glass to the piece of cardboard where you got that nice image of the candle flame. Okay, so you got that? Alright, now you're going to put this information into the table that is in your lab. So it says focus measured outside. Okay, then it says actual focus from envelope. Well, we don't know what the real focus is of your lens, so just leave that blank. Okay, distance from the object to the lens measured, so you can do that. So that would be the distance from the candle is the object, to the lens. Okay, distance from the lens to the image. Well, the image is the piece of cardboard. So you can measure that distance and then put that in the lab. And then it says to calculate where the image should be. So in order to do that, we're going to make use of the formula that is under the concept introduction. So I'm scrolling up to the concept introduction, and equation 17.2 says that the location of the image of an object projected by a lens can be calculated using the following equation. So it's equation 17.2. It says 1 divided by the focal length, f, is equal to 1 divided by the distance to the object plus 1 divided by the distance to the image. So you got your focal length from outside. So that was this distance here down to the ground when you had the sun going through your magnifying glass. So that's your f. But you need to take 1 divided by f. So that if your focal length was 2 centimeters, then 1 divided by 2 would be 0.5. So that would be 1 over f. Okay? You know the distance from the candle to the magnifying glass. So that's the object distance. So you're going to take 1 divided by that number. Okay? Now the problem is you don't know what the distance from the magnifying glass is to the screen. Let's pretend that you don't know that number. You're going to calculate it using equation 17.2. Be very careful with your calculations when you do this. This is very similar to what you've already done with resistors. Remember when resistors were in parallel and you had to take 1 over the total resistance equaled 1 over resistor 1 plus 1 over resistor 2? So it's very similar to that, but be very careful with your algebra. You're going to solve it for the image distance and then compare it to what you measured with the ruler. And hopefully those two numbers will be very similar to each other. Okay, so that pretty much wraps the thing up. Now you're still going to do your post-lab questions. So don't forget to answer all of those post-lab questions. Let me just make sure that... Okay, question number 6. When would you want to use a plane mirror, a flat mirror? So what's the usefulness of a flat mirror? Okay, then what's the usefulness of a concave mirror? It does have its use. So you might need to look that up on Google. Okay, and then what's the usefulness of a convex mirror? Look it up on Google. Okay, when would you want to use each of the following? So now you've got the plane lens, like the aquarium. Is there a usefulness for being able to bend light like that? Maybe you ought to find that on the internet. Okay, same thing for the converging lens and the diverging lens. Now, especially if you wear glasses, you use converging lenses and diverging lenses, depending on if you're nearsighted or farsighted. So you might want to look that up on the internet, nearsightedness and farsightedness, and then find out what kind of lens is used in each of those two cases. Okay, question number 8. Okay, this time an object is located 10 centimeters in front of a converging lens that has a focal length of 3 centimeters. Where would the image be formed at? Well, that's exactly what you did in lab. So do another calculation for me just to verify that you know how to use that formula. So that's it. Finished with this lab, and I will see you then in class. Bye.